So as we have linear momentum, in the same way we have angular momentum in rotational motion. See, what is linear momentum? Hmm? Linear momentum is mass into velocity. Okay. So unit of linear momentum is kilogram meter per second. And please define linear momentum. Mathematically, it is mass into velocity, right? So it is the quantity of motion contained in an object. Momentum is the quantity of motion contained in an object, right? So this is linear momentum. This is how we write linear momentum. And unit of linear momentum is kilogram, unit of mass, and then we write unit of velocity. It's kilogram meter per second. Okay. Now here in rotational dynamics, we replace this linear momentum by angular momentum, L. Angular momentum, L. And because we know mass is replaced by moment of inertia, it is denoted by capital I. And V is the linear velocity and it is replaced by angular velocity omega. So L is I omega. L is I omega. Now what is the unit of this moment of inertia? It is mr square, no? And this V is r omega. This is how we write. V is r omega and omega is V by r. So unit of omega is radian per second, or we can simply write per second. Unit of moment of inertia is kilogram meter square. So unit of angular momentum is kilogram meter square per second. Okay. One more relation we know between force and linear momentum. And we say that rate of change of linear momentum is directly proportional to the external force applied on the system, right? And this is how we write F is equal to dP by dt. So in the same way, here in angular momentum, F is replaced by, we have done in the previous class, torque, and linear momentum is replaced by angular momentum. So we can write like this, tau is dL by dt. Okay, clear? One more thing we know that we have read about conservation of linear momentum. Conservation of linear momentum, and what is it? Momentum is conserved. The condition is terms and conditions apply. बताओ बताओ. If there exists no external force on the system, if external force is zero, then dP by dt is zero, right? And therefore, derivative of a constant is zero, right? So we can say that momentum is conserved. Same concept can be applied here in angular momentum. We can say that if there exists no, in place of force, I'm going to write torque this time. If there exists no external torque, then tau external is zero. This implies dL by dt is zero. And therefore, angular momentum is conserved. इतना इजी हो गया सब कुछ बताना और हमने टॉपिक कंप्लीट कर लिया. बट ये इतना देखो, बिकॉज इजी क्यों था हमारे लिए? इजी इसलिए था बिकॉज वी हैव ऑलरेडी डन ट्रांसलेशनल मोशन, वी नो ऑल द रिलेशंस, ऑल द वेरिएबल्स. तो हमने बस उसके कॉरेस्पॉन्डिंग जो रोटेशनल मोशन में वेरिएबल्स हैं उनको लिखा और हमारा टॉपिक खत्म. ठीक है. सो हियर इन दिस टॉपिक विल गो स्टेप बाय स्टेप. ठीक है. हम सब कुछ ये धीरे 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 विल गो स्टेप बाय स्टेप, विल प्रूव ईच एंड एवरीथिंग. ये यहीं पे ही खत्म नहीं होगा, इसको हम प्रूव करेंगे. ठीक है. और ये इसका डिटेल में जाएंगे. तो अभी जो आपने किया है ये सिर्फ एक ओवरव्यू है कि एग्जैक्टली हम इस चैप्टर के इस टॉपिक में वी आर गोइंग टू डू दिस. ओके. शुड आई क्लियर द स्क्रीन? Okay, now let's start the topic, angular momentum. So angular momentum is the rotational analog of linear momentum. Okay, it is a vector quantity. And if we consider a particle which is placed, we can say that in XY plane, okay, draw coordinate axis first. So we have a particle here at this point, and the position vector, the position coordinates of this particle is, let's say, xy, and the position vector, we usually denote position vector by vector r. This is vector r. So this is the position vector of this particular particle, and this is origin. We can write O here. Okay. Now this particle which is present at P, it is moving at a certain point of time. Now it is moving with some velocity vector v along this direction. Okay. And mass of this particle, we can take mass of the particle as m. So we can write angular momentum. See, linear momentum we know. Linear momentum is also a vector quantity. Linear momentum is vector p is equal to m vector v. ठीक है. अब जो आपका एंगुलर मोमेंटम होगा, एंगुलर मोमेंटम के लिए क्या करेंगे हम, यू कैन सी दैट दिस इज द वेलोसिटी, दिस इज द डायरेक्शन ऑफ वेलोसिटी ऑफ द पार्टिकल. ठीक है, और ये वेक्टर आर हो गया. सो वेक्टर वी इज इन दिस डायरेक्शन, और वी कैन से इफ वी इज इन दिस डायरेक्शन, पार्टिकल हैज मास m, so we can say momentum is in this direction. है ना, this is the direction of momentum because momentum is mv vector. The direction of velocity and direction of momentum, they are the same, right? And the direction of r is this. So we can extend this vector like this. We can extend this vector like this. Now what is the angle between vector r and vector p? The angle between vector r and vector p is theta. Clear? Okay. Now we can write our angular momentum as vector L is equal to cross product of vector R and vector P, as we write for torque. Torque के लिए हमने क्या लिखा था? R cross F. In the same way we can write for angular momentum. It is vector R cross vector P. So we have these two vectors in a plane. Because in cross product we know na, the resultant vector is perpendicular on both the vectors. If we have vector r and vector p in xy plane, then this resultant vector, vector L, is in perpendicular direction. This vector L is perpendicular to both vector r and vector p. Okay, because ये क्या है, क्रॉस प्रोडक्ट है. क्रॉस प्रोडक्ट में हमेशा जो रिजल्टेंट वेक्टर होता है वो गिवन वेक्टर्स के परपेंडिकुलर होता है. एक चीज तो ये आ गई समझ. ठीक है. सो वी कैन राइट एंगुलर मोमेंटम. प्लीज राइट दिस. Angular momentum vector L about O as, let this point be K. Okay. And we can also resolve this into components, no? Extend this. This angle is theta. Because this angle is theta, this angle is also theta, right? This angle is theta. So this is also theta, vertically opposite angles. So we can write this as r cos theta. We can resolve this vector r into components, right? So this is r cos theta and this is r sin theta. Let this point be B, this point be A, KA vector. Okay, KA is the direction of velocity vector and this is the direction of position vector. Okay, so we can write vector L as vector OK cross. OK is the position vector and MV vector. So position vector multiplied by momentum vector, right? It is the cross product of position vector and momentum vector. Or we can write this as MV OK sin theta. Okay. Now what is this MV? MV is P and OK is R. So P into R sin theta. And R sin theta is nothing but OB. Look at this. This is OB, right? So we can write in place of R sin theta, we can write OB. So this P is the linear momentum. And this OB is the perpendicular distance of the line of motion from O. Please write this vector L, and we can write this vector L as vector R cross vector P. So vector R cross vector P is R P sine theta. Okay. So now look at this. Either we can write this RP sine theta as R in the bracket, we can write P sine theta, or we can write P outside the bracket, and in the bracket we can write R sine theta. Okay. If we write P sine theta, what does it mean? This is R P perpendicular. P perpendicular is P sine theta. So it is the component of P. It is the component of P in a direction perpendicular to vector R. Okay. And here if we write P into R sine theta, then we can write this as R perpendicular, P R perpendicular. Now this R perpendicular is R sine theta. So we can say that it is the perpendicular distance of the directional line of vector P from the origin. अच्छा, अब आपका जो एंगुलर मोमेंटम है, when do we say that angular momentum is zero? When is angular momentum zero? Because we know that angular momentum is vector R cross vector P, or we can write this as R P sine theta. This is the magnitude, right? This is the magnitude of angular momentum, we can say. So angular momentum is zero when, number one, either R is zero or P is zero. ठीक है? और yes, theta is either 180 degree or 0 degree. If theta is 0 degree, then sine 0 degree is 0. If we take theta as 180 degree, then again it is 0. Angular momentum. Angular momentum is a physical quantity analogous to linear momentum in translational motion. It is also called moment of linear momentum of the body. As we call torque as moment of the force, in the same way we can call this angular momentum as moment of linear momentum. You can write this. Okay, please add this in your notes. And angular momentum is given by vector L is equal to vector R cross vector P, or we can write the magnitude of vector L as RP sine theta. P is mass into velocity. So in place of P, we'll write mv. So it's mvr sine theta. Unit of angular momentum is kilogram meter square per second, and dimension of angular momentum is, you tell me. For kilogram, it's m. For meter square, it's L2. For per second, it's t minus 1. Okay, so these are the dimensions of angular momentum. So consider a rigid body. This axis, you can see this is the axis of rotation, and we have, this system. It consists of n number of particles, m1, m2 to mn. Okay, these n particles are present in the system, and they are at distance, perpendicular distances from the axis of rotation is R1, R2, R3, R4, or to Rn. This is how we can take. This is what we always do. We consider an axis of rotation and all the particles of the system. They are of different masses and they are at different distances from the axis of rotation. And we always take distance from the axis of rotation. Okay? So let the angular velocity be omega. We assume that linear velocity, because we all the particles, they have their individual velocities, but angular velocity is constant for the system. तभी लिखते हैं ना हम v1 is equal to r1 ओमेगा, v2 is equal to r2 ओमेगा. याद करो, भूल गए? ठीक है. Therefore again आ गया, v1 is equal to r1 ओमेगा, and similarly others, v2 is equal to r2 omega, v3 is equal to r3 omega, Because देखो सबका जो डिस्टेंस रिस्पेक्टिव डिस्टेंस है फ्रॉम द एक्सिस ऑफ रोटेशन इज डिफरेंट, है ना. द पार्टिकल ऑफ मास m1 is at distance r1. Its linear velocity is v1. So, but angular velocity is constant. Okay, angular velocity is constant. So, linear momentum. How do we write linear momentum? Mass into velocity. So, for first particle, it is m1 v1. For second particle, it is m2 v2. It goes like this. So, in place of v1, we can write r1 omega. Okay. So, m1 v1 becomes m1 r1 omega. Please write this. लिखते जाओ साथ साथ. m1 v1 becomes m1 r1 omega. Okay, and for mass m2, again, it's m2 v2. v2 can be written as r2 omega. Clear? Similarly, we can write for nth particle of mass mn. Its angular momentum is pn. It's m1 vn, and vn is written as rn omega. Now we have individual momenta of all the n particles that we have in the system. They have different masses. They have different linear velocities. They are at different distances from the axis of rotation, and therefore they have different linear momentas. Okay, clear? Now, because we know that L is PR, sine theta, or we can say PR. When do we take PR? When theta is 90 degrees. So L1 is P1 R1. So in place of P1, we can write M1 R1 omega into R1. Okay, so it's M1 R1 square omega. So this is, this you can use as a formula for angular momentum. It's mr square omega. This is a general formula. You can use it. I omega, mr square omega. I is mr square, right? This we have discussed, right? So similarly, we can write for second particle. Angular momentum of the second particle is m2 r2 square omega. And angular momentum of the third particle is m3 r3 square omega. For nth particle, we can write like this, mn rn square omega. We are just following the pattern. Okay. So angular momentum of various particles in the system, we can add these. Okay, omega you can take common, and in the bracket you will have m1 r1 square plus m2 r2 square to mn rn square. So this can be written as summation over I is equal to 1 to n mi ri square, and omega belongs to all, so we have written this outside the bracket. Okay, we can take this outside. Now this summation over I is equal to 1 mi ri square omega. This is what we have, and we know that the thing which is in the bracket is nothing but is moment of inertia, right? So in place of the, this expression, we can write I. So hence we have this relation, L is equal to I omega. Angular momentum into angular velocity. Okay. Now answer the questions. First question is, yes, please answer this. Which physical quantity is expressed by the moment of linear momentum? Yes.
Angular momentum.
Yes, angular momentum. Next question. Which physical quantity is represented by the product of moment of inertia and the angular velocity? Angular momentum. L is equal to I omega. Third, write the dimensional formula of angular momentum. Is it a scalar or a vector? It is a vector quantity. Dimensional formula is m1L2 t minus 1. Name the physical quantity whose dimensions are same as that of angular momentum. Hmm? Do you know the answer? It's Planck's constant. Planck's constant. What is the value of Planck's constant? E is equal to h nu. सुना हुआ है? कहीं ना कहीं तो सुना होगा. Value is 6.6. Yes, into it's minus 34. As for minus 34, unit is it's joule second. Next question. Which physical quantity of linear momentum does not contribute to angular momentum? Physical component, sorry. Which physical component of linear momentum does not contribute to angular momentum. Which component means radial component or axial component? Radial component. Next question. Show that the angular momentum about any point of a single particle moving with constant velocity remains constant throughout its motion. Please write these questions. These questions are important. And I have taken all these questions from your assignment that I had given you. ठीक है? तो ये यहाँ पे डिस्कस करने का मतलब ये है कि ये असाइनमेंट नोटबुक में भी हो जाने चाहिए. ठीक है? Now we have to prove that angular momentum about any point of a single particle moving with constant velocity remains constant throughout its motion. If the object is moving with constant velocity, then linear momentum is, look at this. Draw this in your notebook. See, if the object is moving with constant velocity, then linear momentum is constant. mv is constant, right? है ना? Linear momentum is constant, mv is constant. Look at this. We have taken two different positions. This is position one of the particle and this is the second position of the particle. In both the cases, object is moving with the same linear momentum mv. Here, because its mass is always constant, right? Velocity changes and change in velocity changes the linear momentum, we can say, right? So here, object is moving with constant velocity. So it has the same linear momentum. But you can see that vector r1 and vector r2 are different, right? And the angles are also different. Position vectors are different. We have different vectors, vector r1 and vector r2. Position vectors are different. And the angles are also theta 1 and theta 2. In the first case, this is case 1. Look at the cursor. We can write angular momentum as vector r1 cross mv, right? It's vector r cross p, right? So vector r is vector r1 in the first case and cross p, mv. So we can write this as mv r1 sine theta 1. mv r1 sine theta 1. And this r1 sine theta 1 is r1 sine theta 1 is the perpendicular component of position vector. And perpendicular component of the position vector is d. So for r1 sine theta 1, we are going to write d now. Okay. Now let's consider the second position of the particle. Okay. Again, because it is moving with the same constant velocity, but position vector and angle is different. So we can write angular momentum as vector r2 cross vector mv. So it's mv r2 and the angle is theta 2 this time. mv r2 sine theta 2. Now what is r2 sine theta 2? Again the same distance d. Because d is the perpendicular distance that we take, right? We take r perpendicular p. ऐसे ही किया था ना हमने. एंगुलर मोमेंटम को हम कैसे लिख सकते हैं? r perpendicular p. r perpendicular is the perpendicular component. है ना? तो d आ जाएगा. In both the cases, we are getting the same value of angular momentum. So it is constant about any point. Clear? Please draw this. क्योंकि ये ड्रॉ करके एंड मैथमेटिकली ही इसको आप प्रूव करोगे. Can a body in translatory motion have angular momentum? Yes. Okay, please justify it. हाँ मुझे पता है. Yes, a body in translatory motion can have angular momentum unless the point about which the angular momentum is calculated is on the line of motion of the body. Okay. Next, a particle moves in a circular path with decreasing speed. What happens to its angular momentum? Angular momentum will decrease because L is R cross P, so R cross MB. So if V is decreasing, L will also decrease. Next heading is conservation of angular momentum. So as linear momentum is conserved when there is no external force, in the same way angular momentum is also conserved when there is no external torque. Okay. So it states that angular momentum of a rotating body is conserved or remains constant. So we have a rotating object here. It is rotating in which direction? Clockwise or anti-clockwise? Look at this. And torque is 0. So if there is no external torque acting on the body, then angular momentum is conserved. ठीक है? So if the external torque acting on the body is 0, then angular momentum is conserved. Conservation का मतलब क्या होता है कि there is no change in angular momentum. So initial angular momentum is equal to final angular momentum. So let's consider a particle rotating about an axis with torque tau, and p is the linear momentum of the particle. Its mass is m, and its position vector from the axis of rotation is r. ठीक है? So by definition, how do we write angular momentum? Its vector L is equal to vector r cross vector p. Okay, so we can write देखो, हाँ, because हम इसमें रेट ऑफ चेंज ऑफ एंगुलर मोमेंटम निकालेंगे, फिर उसको जीरो करेंगे ना, तो डिफरेंशिएटेड विद रिस्पेक्ट टू टाइम. So on differentiating angular momentum with respect to time, we get, we can apply product rule here. What is product rule? First we differentiate the second multiplied by first term, and then we write the first term. First we write the first term as it is and differentiate the second term, and then we write the second term and differentiate the first term. ठीक है? This dr by dt is v, and dp by dt is vector f. Rate of change of linear momentum is vector f. Okay, and what is this vector p? P is mv. Linear momentum is mass into velocity. Force is dp by dt, and v is dr by dt. So in place of all these expressions, we can write this. Now you see, we can write for dp by dt, we can write vector f. ठीक है? p के place पे we'll write m vector v. Cross we have vector v again. So vector product है ना, same vector का by itself gives 0, because the angle between the two vectors is 0 degree. The vectors are coinciding, right? Same vectors coincide. Theta is the angle. It's 0 degree. Cross product है sin 0 degree 0 होता है. ठीक है? So we have r cross f. R cross f is torque. So dl by dt is torque. So if the resultant external torque acting on the particle is 0, if torque is 0, then dl by dt is 0, and derivative of any quantity is 0 when the quantity is a constant. This implies vector L is a constant or conserved. Okay, and how do we write L in terms of I and omega? We write I into omega. Okay, so initial angular momentum is equal to final angular momentum. I1 omega 1 is equal to I2 omega 2. देखो वेक्टर L अभी जो हमने किया मैं सेम रिपीट करने वाली हूँ. ठीक है, वेक्टर L is vector R cross P, right? So tell me the next step. We are going to differentiate this. So differentiating with respect to T, we get, you are going to tell me everything, okay? Now what should I write? dl by dt. Therefore, this is also equal to d by dt of r cross p. पहली गलती जो बच्चे करते हैं, dr by dt क्रॉस dp by dt कर देते हैं, बिल्कुल गलत. ठीक है, तो हमें इस एक्सप्रेशन को d by dt करना है, सेपरेटली नहीं करना है सबको अलग अलग. मल्टीप्लीकेशन है बीच में, ऐड नहीं हो रहा. जब अगर बीच में प्लस साइन होगा तब डी बाई डी टी ऑफ आर और डीपी बाई डी टी करोगे, लेकिन बीच में क्या है, मल्टीप्लीकेशन हो रहा है. तो इस टर्म, पूरी टर्म को डिफरेंशिएट करना है विद रिस्पेक्ट टू टी. फर्स्ट मिस्टेक यहाँ होती है बच्चों की. ठीक है, जो हमने नहीं करनी है. नाउ विल अप्लाई प्रोडक्ट रूल. ओके, सो फर्स्ट डिफरेंशिएट द फर्स्ट टर्म and multiply the second term, plus sign, Now write the first term as it is and differentiate the second term. So this is product rule. This we have done in differentiation. Okay, now what is this dr by dt is? Vector v. And this p can be written as mv vector plus vector r cross dp by dt is vector f. This first part of this expression is 0. Why 0? Because v cross v, vector product of a vector by itself is 0. Why 0? Because we write the magnitude of first, magnitude of second, and the angle between them is 0 degree. Sine 0 degree is 0, so this is 0. And plus r cross f. R cross f is torque. ठीक है? अब condition क्या है कि if external torque on a system is 0, then angular momentum is conserved. This is the statement. ठीक है? So put external torque equals to 0. So this implies dl by dt is equal to 0. Derivative of a constant is 0 and therefore L is conserved. ठीक है? जैसे इंटरनल फोर्सेस 0 हो जाते हैं ना एडअप होके, इन द सेम वे जो इंटरनल टॉर्क्स होते हैं वो भी हमारे एडअप होके क्या हो जाते हैं? एडअप टू 0. ओके, इंटरनल टॉर्क्स एडअप टू 0. दीज आर इंटरनल टॉर्क्स. सो एक्सटर्नल टॉर्क्स ही होते हैं जो रिस्पॉन्सिबल होते हैं चेंज के लिए, राइट? अब नेक्स्ट second method. Second method, because we know that angular momentum is moment of inertia into omega. So this implies we can write dl by dt as I d omega by dt. Now this d omega by dt is rate of change of angular velocity. Rate of change of angular velocity is angular acceleration. As f is equal to ma, f is equal to ma. In the same way, we can write for torque as in place of m we can write I. In place of a we can write alpha. Okay, so this is torque. So if total external torque, write this in your notebook, on a system is 0. If total external torque on a system is 0, then angular momentum is conserved. ठीक है? अब अगर हम दो सिचुएशंस कंसिडर करें कि इनिशियल एंगुलर मोमेंटम इज I1 ओमेगा and final angular momentum is I2 omega 2. So we can write I1 omega 1 is equal to I2 omega 2. एक और हमने इसमें फॉर्मूला किया था ना L का, इसके अलावा वो क्या था? mr square omega. Which physical quantity is conserved when a planet revolves around the sun? Hmm? बताओ. See, when a planet revolves around the sun, there exists no external torque. No external torque acts on the system, and therefore angular momentum of the planet remains constant, or angular momentum is conserved. Okay. Next, why there are two propellers in a helicopter? बताओ. Why there are two propellers in a helicopter? Hmm? Read the answer first. If there were only one propeller in the helicopter itself would have turned in the opposite direction to the direction of motion of the propeller due to conservation of angular momentum. Thus, two propeller provide helicopter a steady movement. ठीक है, अगर एक ही प्रोपेलर होगा तो क्या होगा, हेलीकॉप्टर जिस साइड प्रोपेलर है उसके अपोजिट डायरेक्शन में मूव करेगा, इसलिए एंगुलर मोमेंटम को कंजर्व करने के लिए, इसलिए दो प्रोपेलर्स होते हैं कि वो स्टेडीली मूव करें. ठीक है. Man and he's standing on a turntable with dumbbells in his stretched hands. The turntable is set into rotation at constant angular velocity omega. If the man now starts to bring his hands closer to his body, we will observe that the angular velocity increases gradually. ठीक है. Why? With wide hands, angular velocity was less, and with hands close to the body, angular velocity is increased. ठीक है. This is the situation. You can draw a free-hand say diagram, draw कर सकते if you want to. So the angular velocity becomes maximum when the man holds his hands. See, because angular momentum is I omega. With wide hands, angular momentum is I omega. With wide hands, moment of inertia increases. अगर एक quantity increase हो रही है तो दूसरी quantity has to decrease to make the product constant. ठीक है. And with closed hands, moment of inertia decreases and angular velocity will increase accordingly. ठीक है. So this can be explained using the principle of conservation of angular momentum. This we have discussed. L क्या होता है, I omega होता है. अगर hands wide होंगे तब उस केस में I greater है तो ओमेगा कम होगा. क्लोज्ड हैंड्स में I is small, ओमेगा has to be greater, तभी प्रोडक्ट इक्वल आएगा ना और मोमेंटम कंजर्व होगा. राइट. So according to this principle, if there is no resultant external torque, L is constant, that is I omega is constant. Angular velocity brings his hands closer to the body, I decreases. ठीक है. Therefore omega increases. This is the second example. What is this about? Diving, है ना. तो अब इसमें you can see the different posture of the swimmer. Again, a diver jumps from a diving board with both the legs and hands kept far off from the body. The diver brings the hands and legs close to the body, increasing the angular velocity. ठीक है. When the diver is near the water, then legs and hands are stretched. इससे क्या होगा, moment of inertia increase होगा और angular velocity will decrease. Third क्या है, ballet dancer का. Ballet dancer decreases or increases the angular speed of rotation by stretching the hands or bringing the hands closer to the body. ठीक है. तो इसमें अगर आप hands को wide करते हो तो आपका angular velocity will decrease because moment of inertia is increasing here. With wide hands, moment of inertia increases and angular velocity decreases. And with closed hands, moment of inertia decreases and angular velocity increases. So in both the cases, angular momentum is conserved. There is no change in angular momentum. जैसा angular momentum wide hands में है, वैसा ही same angular momentum closed hands में भी है. It's like if you want 12, then either you can multiply 4 and 3 or you can multiply 6 and 2, right? तो 4 to 6 करोगे अगर तो 3 से 2 जाना पड़ेगा. मतलब अगर आप एक नंबर को इंक्रीज करोगे तो दूसरा नंबर डिक्रीज करना पड़ेगा, तभी प्रोडक्ट कांस्टेंट आता है ना. So these are the three examples. You please read the question first. See, here we have, children please listen. यहाँ पे क्या है? What will be the duration of the day? So what is the duration of the day? It's 24 hours, right? Earth completes its one rotation in 24 hours. So what will be the duration of the day if Earth suddenly shrinks to 1/64th of its original volume? Mass remaining unchanged. We are not changing the mass, we are only changing the radius of the Earth. Okay. So this is the present size of the Earth, and after shrinking, this is the size. Okay. So let the present volume be V1. ठीक है. और shrink होने के बाद volume क्या हो गया? V2. Radius is R1 और shrink होने के बाद radius क्या हो गया? r2. टाइम पीरियड ऑफ रोटेशन अभी क्या है t1, इट्स 24 आवर्स, एंड श्रिंकिंग के बाद टाइम पीरियड विल चेंज टू t2. We know that angular momentum remains conserved. Angular momentum remains conserved. ठीक है. See, if the earth suddenly shrinks to 1/64th of its original volume, we are not changing the mass, only volume is changing. So we can write that v2 is 1 by 64 v1, and earth is a sphere. We can assume earth to be spherical in shape. So how do we find volume of a sphere? It's 4 by 3 pi r cube. So we can write 4 by 3 pi r1 cube is equal to 1 by 64. In the bracket, we will write 4 by 3 pi, sorry, this is R2, right? Pi R1 cube. 4 by 3 pi cancel हो जाएगा. We are left with this R2 cube is equal to 1 by 64 R1 cube. Or we can write this as 4 4 the 16, 4 the 64, है ना? 1 by 4 R1 whole cube. Now on comparing these two, we get R2 as 1 by 4 R1. ठीक है? So radius becomes 1/4 of the original radius. ठीक है, एक चीज समझ आ गई. अब हमने क्या करना है, देर इज नो एक्सटर्नल टॉर्क एक्टिंग ऑन द सिस्टम सिंस there exists no external torque. Write this, you have to write this, acting on the system, therefore angular momentum is conserved. ठीक है, अब क्या करेंगे, how do we find angular momentum? Angular momentum is I omega. Do we have angular speed or angular velocity of the planet? No. We have time period. Can we relate omega with t? What is the relation between omega and t? It's 2 pi by t. ठीक है, I into 2 pi by t, this is a constant. And see, because 2 pi is a constant, so we can write I by t is a constant, right? है ना? अच्छा, moment of inertia of a sphere, we don't know. क्या होता है? 2 for sphere, solid sphere. It's 2 by 5 mr square. I is 2 by 5 mr square. ठीक है, ये हमें पता होना चाहिए. ठीक है, अब बिकॉज I by t कांस्टेंट है, सो वी कैन राइट I1 by t1 is equal to I2 by t2. What we have to find? We have to find the value of time period, है ना? So we have to find t2. We can write this as I2 by I1 into t1. Can we write like this? This I2 by I1 now. I2 is 2 by 5 m R2 square, and I1 is 2 by 5 m R1 square into T1. 2 by 5m, 2 by 5m cancel हो जाएगा. ठीक है, where do I write now? I'm going to erase this. Should I? ये erase कर दे. So T2 is R2 by R1 whole square into T1. R2 by R1 is, from here we can find R2 by R1 as 1 by 4. So we can write 1 by 4 whole square into T1 is 24. हाँ जी, बताओ क्या आंसर आ रहा है? 3 by 2, or in decimal we can write 1.5 r. So this is your answer. ठीक है, children please read the question. Two disks of moment of inertia I1 and I2 about their respective axes normal to the disk and passing through the center and rotating with angular speeds omega 1 and omega 2 are brought into contact face to face with their axis of rotation coincident. ठीक है? Show that angular speed, calculate angular speed of the two disk system and show that the kinetic energy of the combined system is less than the sum of the initial kinetic energy of the two disks. And how do you account for the loss of energy? Take omega 1 not equal to omega 2. बताओ भाई कैसे करेंगे? सो इनिशियली हाँ बिल्कुल ठीक कर रहे हो. देखो यहाँ पे क्या है बहुत ध्यान से देखना है. वी हैव टू डिफरेंट डिस्क. ओके, डिस्क 1 एंड डिस्क 2. Okay, their moment of inertia is given. Moment of inertia of disk 1 is I1 and that of disk 2 is I2. Angular velocities are given. Its angular velocity is omega 1. Its angular velocity is omega 2. We can write their angular momentum. Angular momentum L1 is I1 omega 1. Angular momentum of disk 2 is L2. It's I2 omega 2. Now we can write the total angular momentum of the system. ठीक है? So total angular momentum is denoted by L and it is equal to I1 omega 1 plus I2 omega 2. Okay? See, अब इसमें क्या है? They are brought into contact face to face with their axis of rotation coincident. So their axis of rotation is coincident and they are brought into contact face to face. So we can write the angular moment of inertia of the two disk system. ठीक है? So moment of inertia of the two disk system is I1 plus I2. ठीक है? If we assume that they are moving with the same angular speed omega, so omega is the angular speed of the combined system. Angular speed of the combined system. Okay, so we can write angular momentum as L dash. It is I1 plus I2 omega. ठीक है? यहाँ पे कोई external torque act हो रहा है? No. So we'll write is as there exists no external torque acting on the system. Therefore, L and L dash are equal. ठीक है? So we can write I1 omega 1 plus I2 omega 2 is equal to I1 plus I2 omega. So from here we can, find the value of omega. We can write omega in terms of these variables. Omega as I1 omega 1 plus I2 omega 2 divided by I1 plus I2. This is the angular speed of the combined system. Okay. तो फर्स्ट पार्ट में आपको एंगुलर स्पीड फाइंड करना था, तो ये हमारा फर्स्ट पार्ट हो गया. नाउ वी हैव टू फाइंड kinetic energy of the combined system and sum of we have to prove that kinetic energy of the combined system is less than the sum of the initial kinetic energies of the two disks. So we can write initial kinetic energy first. So what is the initial kinetic energy? Initial kinetic energy, how do we write kinetic energy? In translational motion, half mv square, and here we'll write half I1 omega 1 square. mv square होता है ना, I1 omega 1 square. This is for disk 1. Similarly, we can write for disk 2. So this is the initial kinetic energy. In the same way, we can write final kinetic energy as half moment of inertia of the combined system is I1 plus I2. And angular speed of the combined system is omega square. नाउ इन प्लेस ऑफ ओमेगा वी कैन राइट दिस, ठीक है, कर सकते हैं ना? ये क्या हो जाएगा, हाफ I1 plus I2, and for omega we are going to write this I1 omega 1 plus I2 omega 2 upon I1 plus I2 whole square. देखो यहाँ पे भी इन द न्यूमरेटर वी हैव I1 plus I2, इन द डिनोमिनेटर एज वेल वी हैव I1 plus I2 स्क्वायर, सो कैंसिल हो जाएगा एक, और वी कैन राइट हाफ I1 omega 1 plus I2 omega 2 square. In the denominator, we can write I1 plus I2. So this is the final kinetic energy of the system. We have to find, we have to prove that kinetic energy of the combined system, that is EF, it is less than the sum of the initial kinetic energies of the two systems. This is what we have to prove. For this, we need to subtract these two and see what do we get. Okay, let's see. So for this, we'll subtract these two, EF minus EI. So EF, or we can do EI minus EF because there is loss of energy, है ना? तो loss of energy है, तो we should always subtract, greater quantity, smaller quantity from greater quantity, right? Because there is loss of energy, है ना? Loss of energy अगर हम assume करके चल रहे हैं, initial बड़ा होगा इसका मतलब, है ना? और final छोटा होगा, तो we can write like this, ठीक है? EI minus EF, so this is half I1 omega 1 square plus half I2 omega 2 square. This is your EI minus half EF is I1 omega 1 plus I2 omega 2 whole square divided by I1 plus I2. Now on solving this, see, you can take the, you can write 1 here and cross multiply this, है ना? After taking the LCM and simplifying, what will you get? I1, I2 in the bracket, we will write omega 1 minus omega 2 whole square. In the denominator, we have 2 I1 plus I2. So we can see that we have omega 1 minus omega 2, but we are taking the square of this. So we have something which is greater than 0, right? I'm going to erase this. ठीक है? If this is greater than 0, it implies that EI minus EF is greater than 0, or we can write EI greater than EF, है ना? इससे क्या मतलब है कि इनिशियल काइनेटिक एनर्जी of the system is greater than final kinetic energy, which indicates that there is loss of kinetic energy. ये loss क्यों हुआ? This implies there exists loss of kinetic energy. And loss क्यों है? It must be due to friction between the disks, है ना? जो disks हमने contact में place किए हैं, वो उसमें frictional force की वजह से हो सकता है. Must be due to friction in the contact of the two disks. देखो जो ये फ्रिक्शन है, ये सिर्फ ये इंटरनल टू द सिस्टम है, इट इज नॉट एक्सटर्नल, ठीक है? तो अगर फ्रिक्शन से कुछ लॉस हो रहा है तो इट इज इंटरनल टू द सिस्टम, उससे एक्सटर्नल टॉर्क जीरो ही रहेगा आपका. एक्सटर्नली तो कुछ नहीं कर रहे हो ना, विद इन द सिस्टम लॉस हो रहा है, अपने आप सिस्टम के अंदर लॉस हो रहा है, तो उसके लिए तो हम रिस्पॉन्सिबल नहीं है, बाहर से तो हमने कुछ नहीं किया, ठीक है? क्लियर? कुछ पूछना है इस पे?